Hey, happy Thursday. Nope, Wednesday, Tuesday. I don't know, the days are all squishing together. Today's Tuesday. You're going to look at this tomorrow on Wednesday. Okay, you did acid base. You did pH. Yesterday you did a little bit of titrations. There's one titration question on the test. Today we're going to talk about a new type of K. So we have regular K, we have special K, we have KW, and today we have KA, which they talked about a little bit in one of those videos. They said there was KA and KB. Ka is for acid, Kb is for base. We're only going to worry about Ka. So when you have Ka, the first thing you need to do is determine if it's a strong acid or a weak acid. You should have a table in your packet. If you don't, email me and I'll get you one. And anything greater than 1 is a strong acid. In that one video they gave you, there's really only 6 strong acids. You don't have to memorize them, but maybe jot them down somewhere so you would know what those strong acids were. The rest are weak, okay? And then anything with an OH at the end typically is a strong base, and without the OH is a weak base. So we're going to start with this. So you have 1 liter hydrochloric acid. Right away, as soon as you see hydrochloric acid, you have to know that that's a strong acid. Okay, it's a strong acid, strong electrolyte, fully ionizes, so it's a little bit different. When you have a strong acid, there's no denominator. So step number 1, when you're doing these problems, step number 1, is it a strong acid or a weak acid? Strong acid. I'll type out these steps and send them to you, so you don't need to write them down. I'll send them to you. 2, what do you do next is you write the balanced equation. So I have hydrochloric acid and because it's a strong acid, it's a one-way arrow, fully ionizes into H plus, Cl minus. Okay. Step number 2, it's balanced. I don't have to do anything. Step number 3 is your K expression. So when you have a strong acid, no denominator. Weak acid, yes, denominator, because some of it's going to come back. Strong acid, you don't have a denominator. So my Ka is concentration of H plus times the concentration of Cl minus. Raised to the power of the coefficient. No coefficients. So because it fully ionizes, there's no denominator. It's all going this way. Okay, step number 4. I need to know, I need to find this, and I need to find this. If it's a strong acid and it fully ionizes, and I start off with 0.1, that tells me that the concentration of H plus equals 0.10 molar. That's just like the ones that you were doing. There's practice problems. If it's a strong acid, that's going to fully ionize, so this would be 0.1. Okay? In order to find the concentration of KOH, you use KW. So KW equals 1 times 10 to the negative 14th. Which equals the concentration of H plus times the concentration of OH minus. So 1 times 10 to the negative 14th, 0.10 times your concentration of hydroxide. So my concentration of hydroxide is 1 times 10 to the negative 13th molar. Strong acid, fully ionizes. I know that then I know this, okay? So it fully ionizes, so because I know this, then I know H plus. Because I know H plus, then I can figure out OH minus. Okay, this is the strong acid. Okay, now we have to do the weak acid. So I put the weak acid on the back side. The weak acid that I picked was acetic acid, like vinegar. Okay, remember we did the demo with the vinegar. It didn't light up. Mr. Schroeder did the demo in his basement. or kitchen, and didn't light up a whole lot. So it's the same problem, but this time I have acetic acid. I know that acetic acid is a weak, so step number 1, it's a weak acid. Step number 2, write out the balanced equation. So I have HCH3. It's aqueous because remember we said these are always surrounded by water. Because it's a weak acid, it's a two-way arrow. So it's not going to fully ionize, it only partially ionizes, so you end up with H+. And then the acetate ion, okay? Now, I need to know my Ka expression. So this time, because it doesn't ionize, I know that Ka is H+. Okay, I only know the concentration of this. I don't know the concentration of this, and I don't know the concentration of this. You have a table. The table has the Kas. So we're going to use that table, and we're going to use an icebox in order to solve this equation. So I know when I look up in the table, it tells me that the Ka is 1.8 times 10 to the negative fifth. I know this. I don't know this. I don't know this. And I don't know this at equilibrium. I only know the initial. Right away, weak acid, you're going to need an icebox. So I'm actually going to erase my Ka. So write it down real quick if you need it. Okay, I'm going to put my icebox right underneath my equation. Okay, so I know that the concentration of this is 0.1 in the beginning, 0.10. I know the initial concentration, so here's my initial, here's my change, here's my equilibrium. This is nothing, this is nothing. Okay, so this is type 5. We know the Ka, and we have to figure out the rest. So this loses X, this gains X, this gains X, so this becomes X, this becomes X, this becomes 0.1 minus X. So now I set up my Ka. Ka equals H+. So 1.8 times 10 to the negative fifth equals X times X divided by 0.1 minus X. Ugh, quadratic equation, gross. We don't really like that. So this kind of is like that one problem where I gave you a hint and I said it was a KSP problem, and I said, oh, just kind of drop the X. So we're going to assume that this change is really small, like really, really small. It'd have to be really small because in order for this to work. So we're going to drop the X down there. Okay, remember, whenever you assume, you have to go back and check your assumption. So I know that later on, I'm going to need to check that assumption. Okay, and remember it has to be 10 to 15% of X. And as long as it's 10 to 15%, then it's totally fine. If it's bigger than that, then you're going to have to go back and do the quadratic equation. It'll always be okay when you drop the x, okay? Well, I mean, it'll be okay in the problems that I give you. It'll be okay to drop the x. So now I have 1.8. Do you see this? 1.8 times 10 to the negative fifth equals x squared divided by 0.1. So I solve for x, and x is 1.3 times 10 to the negative 3 molar. This is most definitely less. So I check my assumption, it's okay. Because if I have 1.3 times 10 to the negative third divided by 0.1, it's definitely going to work out okay. Okay, so then if this is x, that means that my H plus concentration is 1.3 times 10 to the negative third molar. So just like on the other side, we now use Kw, 1 times 10 to the negative 14th has to equal the H plus times the OH minus, and you solve for the OH minus. Okay, so step number 1, strong acid, weak acid. If it's a strong acid, fully ionizes. Weak acid, you're going to need to do this. Okay, if it's a weak acid, you need to set up an ice box. Okay, you need to remember about your coefficients when you set up the ice box. So I give you a nice one where the coefficients are really easy. Okay, then you solve for x. X is going to give you that concentration H plus, because look, here's my H plus. And here's x. And then you use that to find your OH minus.